After sharing the screen. Yeah, so here is the screen. So in today's lecture, we will be discussing about classes and objects in continuation with our week 9 lecture. So in this, we talked about the different type of associations, and also we will be talking about the how to use the static modifiers and static variables. So to begin with, static modifiers. So the static keyword in Java is used for class level members. So whatever the variables that you are going to define, both as the variables as well as the methods that can be declared as static. So this means the variable or methods belongs to the class itself, not to objects. So whatever the variables that you are defining, that one will belong to the class itself, not to the objects. So the things will get clear when we go and look at the example. So using instant variables, each instant of a class created with the keyword new creates a copy of all instance variable in that class. So previously you saw that when you created an object with the new for a class, so whatever the variables that you have defined inside a class, they will all become also a copy of that to the objects that you have created in reference to that of the class. So in this example, you can see here that in the employee class below, a unique copy of the last name and first name is created for new each employee object that is created in a driver class. So see here, for example, we are having public class employee and the variable is private string last name. And also we have a private string as the first name and you have the code. So both the strings are declared as private. And now in the driver class, what I'm going to do is I'm creating an instance of the class with an employee E1 is equal to new of employee. So I have given the private name and the last name and the first name for employee 1 and E2, the first name and the last name. So the variables that you are having inside a class are accessible over here. And depending upon the reference, it will create the objects that we have. And remember, we said about the constructor, and the constructor is the name as the same as the class, and you can have the parameters inside the class to call it based on the arguments. So what we know now, static variable, one copy is shared by all objects. So if you are having a static variable, one copy will be shared by all the objects. And as well, static methods can be called without creating an object. So you can call them without creating it. So, but here we are not making it as a static. This is just normal variable. But later on, when we are making as a static variable, so that static variable that can be shared by all the objects. So now let's look at how to make these class variables and class members as a static variable. So we use the word static. Okay. So static is a keyword in Java that modifies the association of an item to a class. So how it is defined and how it is referred. So content of a class that are identified as static or shared across all the instances of the class. So let me just jump directly to an example here. So we are having here two employee objects, E1 and E2. So now we have two different instance variables, the first name and the last name that you previously saw. So instance variables were Mary Smith, the first name and the last name. And for another variable, the instant variable was Sally and Jones. So now we want to have a static variable for both of them, and that's where we will declare it directly as a static variable. So it means that all the instance of the class share one copy of the static items. So whenever you are declaring as a static variable, so that will be shared among all the objects, and each have their own unique copies of instant items or non-static items. So these two are non-static items, but static items will remain the same. So here you can see that consider initializing a string, static string with the value Oracle. So my company, that represents the employer's company. Each instance of the employee would still have their unique instant variables, but would share the static variable. So the static variable here, Oracle, will be shared by all of them because this is declared as a static variable. Now, so static variables are also known as class variables. They are declared using the keyword which is static, and they have only one copy in the memory as opposed to instant variables which hold one copy per instance. So previously you saw that we were having instances, everyone gets one copy if they are non-static. But if they are static, all of them will use the same instance of that variable. So all shared by the object instances hold the same value for all the class instances. So when you are having a static variable, they will say all the instances would remain the same. So in this case, if you are making it as public also, so for public for static variables, if public, they can be modified directly by other classes because you are making it as public, so they can be modified by other classes. So consider making a variable a constant by using, so we want to make it as a constant by using the keyword which is final. So we are using a final keyword and that makes it as a constant. The data type is integer. The variable name is going to be model underscore num, and this is you are giving some value. And then also the important part is here we are making it as static. So static means this one will be used by all the instances of the objects and it is not going to be changed. Okay. So let's look at a working example. So you can see here that we are declaring a class student, and now we are making a variable which is static, and this is integer count is equal to 0. So it means that it will be shared across all the objects. Now we are having an instance variable name, class name, that is string of name, and we are having a constructor student string of name, and this dot name is equal to name, and we want to just keep a counter for count plus plus. So when you make it as a static, you can use this for all the instances on the class constructors as well. Now go to your main method. You can see that student S1 is equal to new student Ali. So because this is directly referred with the constructor here, we are having only one parameter. So we are calling the constructor with a one parameter. Similarly, we are calling second time. Similarly, we are calling third time. So as many number of times it is being called, it has to increment. So here we are having count plus plus, and this one is make that a static. So it will keep on incrementing it. And at the end, if you are having how many number of times these instances are created for the object or the class, so it will count and it will give you the number of students that we have counted. So we are having a static variable declared inside the class. So static methods are called using the class name. Remember this point. So generally the static methods, we are talking about the methods, they are called using the class name. They cannot access non-static variables directly. So if you declare it as a static method, you have to call it using the class name. Now let's look at this example. Class mathUtil, and then we are having a static method, static integer add a and b and return a plus b. So this class has got only one method. Now when you go to the main driver class, public static void main integer result is equal to. So what did we say here? You have to use the class name to access the static methods. So what is the class name that we are having here? MathUtil. So if you want to use this method, so you have to create math.util with the method that you are going to add. So we are going to have. So we are not creating an object. So no object is needed. If you are having the non-static variables directly, we cannot access it, but static methods, if they have a static method, they can access. So we are generally what we do, we create a method saying that mathUtil m1 is equal to new of mathUtil, and then we call with m1 dot add and all those things. So, but here we are having a static method. So if you want to use that, you can directly call in that particular order. So static variable, it is shared across all the objects. Just remember this table. So static variable means it is shared across all the objects. And how do you use it? Class name dot variable. Similarly, if you are having a static method, it is used for utility functions. No object is needed for this to be done. So we can call it directly with class name dot method with directly what we are doing in this particular example. So the good programming practice is that good programming practice initializes static variables with values rather than relying on default null or zero values. Like what we did it in constructor, we were having the default value as zeros and as nulls. But rather than that, if you are using any static variables, it is always a good practice that you are having some initial values for that one. So the values initially assigned can be changed as long as the class is active in Java Virtual Machine memory. So you can change it, but it is recommended to have some value. So if the values are not utilized, then we have something what is called as garbage collection. So garbage collection removes it from the memory and initializes values assigned will return the next time you use it. So uh, memory utilization will be very efficient. So how do you declare a static variable? You previously saw that to declare a static variable, you need to include the keyword. It can be public method, protected, default, or it can be a private. Should have assigned value, as we previously saw that it is best to assign some value automatically or assign null values. An empty string with zero or based on the primitive numbers should act as a constant with the final keyword when they are used as public, protected, or default. So if you want to make the value as constant, you can use the final and the data type that we are using it. So here we are declaring a public static variable. So now changes to a static variable. So now you want to change the value. So as you previously saw that you can use the instance of the variables directly to change the values. And now if I want to change the value of an instance variable with the static, how you can do that? The static variables that are not final can be read or assign new values. So it's okay. So if you are having some values which are not final, you can change them. By using the optional keywords, this is instance methods. So changes by instance methods are changed for all the instances. Because it is static, it will change for all the places. A change to a static variable may indicate that the class should be limited to only one object. So if it is for one object directly, it relates to that. So you can have a look at this example. So private, we are having one static string variable, and that variable name my company is equal to Oracle. And then we are having a public method, public void set my company with string s. So this company, so the name is set company as a method, string s, and this one. Now you are doing what here? You are creating a static string variable, and you are having a method just to declare this as a company name. Further, if I say here for an example, since each turtle is a different age, it is best to make this variable a private instance variable than a static one. So you can see here that we are declaring a public class as turtle, and we have here public static string food type is equal to turtle food. So similarly to that, public static string food is equal to, we are giving some name, and we are making it as a one more variable as member as private integer age. Now, when I create a constructor, public turtle integer age, so because this is not static, you can see that this age, which is not static, this dot age is equal to age. So in this case, what happens? The turtle name is going to be, food is going to be fixed. The only change will be in the age when we are creating the instance of that particular object. So you can see here that public class turtle, public static string food, turtle feed, and you are having an age. Now, whenever I want to print the age and those things, so you can access the static variable without creating an instance of the class. So you can directly, with static variables, you can call them as we previously saw that. No need to create an instance of the class, you can call it directly. So in a main method, this statement would print out the variable food without any instance reference. So I feed turtle food, whatever the turtle food that you are going to use. So this is the class name turtle that you are having, and then you are having the variable for member as food, and then you can directly get it here. So this is for getting the variable. And also previously you saw that you can call, if you are having any methods also, then you can call directly the methods without creating an instance of that variable. So the conclusions here, static or class methods exist once, so they exist once and are shared by all the class instances, may be used by other classes methods or instance based on the type of modifier, access modifier, cannot access non-static. So you don't have access to non-static or instant variables. Static methods can only access static variables. So these are the points that you need to note it down. So cannot access non-static or instance methods even. Static methods can only access other static methods. So if you are having a method declared as static, then only the static methods can accessible by them. Can be redefined in subclasses. So you can use the static method and redefine them. So they can be used for public, protected, default, or private, as you previously saw. So there are difference between calling an instance method versus a class method. So you saw that how you call an instance and how do you call a class method for with the objects. So for example, you must first create an instance and then use a dot notation. So where you are creating to call an instance method, whereas this class name, a dot notation, if you are using a static method. So if you use the static method that previously you saw here that you were using the class name and the member that you are going to define here. So here the static method that you are defined here. So you are using a dot notation with a class name. As you can see, the class name is here, and with the dot notation, we are calling the instance methods or maybe the variables itself directly, static variables itself. So the other example is creating class instance using static method. So you can see here that we are having public static as a method, and the name of the method is nesting, same as overloading and get instance. So we are having the class name as nesting, and we are creating an object is equal to new of nesting, and then we can return it over here. So when you create an object, nesting n1 is equal to, so here we are having n1 as an instance of an object, and you want to get this instance. So you can directly call this one with the class name. As you saw that, we are calling this one directly with the class name to get the instance of that. Right, so that was in detail about the static. And now relationship. So this is very important topic when we discuss about object-oriented programming, and we want to talk about the relationship between the classes. So why do classes relationship matter? What do you mean by this? So you are having class 1 and you are having class 2. So there should be some relationship between class 1 and class 2. So what is that relationship and why do we need it? You have many classes. So see, for example, you have C1, C2, C3. So class C1 is implemented, class C1 is implemented on this one, or class 1 is using this. So how to do that work is what we will discuss now. So Java is built on object-oriented programming concept. We already know that. And we know that classes are blueprints, but they don't exist in isolation. So if you have a class, it's of no use until you are using it to refer it with the objects that you create. So code reuse, using the relationship, we can reuse the code. So for example, some of the code that you are having in C1, you can use it for C2 for the class. You have already declared some methods over here and you want to use it here, you can do that. Or you want to use something which is declared in C3 and you want to use it in C2, you can do that one. So for that, the class reuse, code reuse will be very helpful from the superclass and subclasses. So what is superclass and subclasses? I will let you know. You are having many classes. Say for example, in this, so C1 is the main class that we have here, is the first class that we declared, and C2 is using this one. So this is called as the superclass, and these are the ones if you are using the data or the methods or the variables from here, we use it as a subclass. So similarly, so C3 is the subclass for C1, and we will make some connection for that one. So the relationship between classes define the architecture and behavior of an application. So how many classes we have and what are the connections that we have, it defines the relationship between them. And it is very flexible and maintenance. If you are having relationship, it is good designs like loose coupling, makes code easier to change, test, and debug. So if you want to make changes to any of the code in C2, you can make changes and you can do it in C3. If not, what will happen is if you write only one class and you are writing every program inside this class, it will be difficult for you to make changes. If you want to make changes, you have to go to the class and make the changes at many different places. Instead of that, what we are doing is we are breaking that code into different classes depending upon our type of application. Say, for example, instead of making one particular class, I can make this class into three subclasses, or one as a superclass and the two as a subclasses. So this is superclass and this is super. So I'll just write here super, and this is subclass SC, and I'll call it as SC. So instead of making as a one particular class, so I can break the code in a way that if anything are used, I can just make it. And if any problem with any of the things goes on, we can go to that particular class and make the changes to that one. No need to go to the complete program and do it all together. So it becomes like a procedural. So that's where if you are having relationship and the classes, it makes code easier to change, test, and debug as well. And that's where we call it as modularity. So because we are making the program into modules, well-defined relationship along you to build complex systems from smaller manageable parts. So you can build a big system just by making the program into smaller parts. So that is what the object-oriented programming concept talks about is polymorphism. So we will be discussing more about the details in polymorphism later on, but the concept is dividing the class into different sections or different subclasses and using them for developing our programs. And that concept is what we call it as inheritances. So you get something as inherited. Inheritance and interface enables polymorphism. So using the inheritance and the connections that you are having between the classes, you get inheritance and inferences referred to as polymorphism, where one object can take many of the forms. So you use one object and you can do it as in different formats. So core class relationship. So we have three different type of relationship in Java. So remember this point, important discussion: association, composition, and aggregation. So what are these? So you can see here from the figure that we are having the first one comes is composition, and above to this is aggregation, and above onto that is association. So, in object-oriented programming, the relationship between classes plays a crucial role in defining how objects interact with each other. So, as I just now mentioned to you that we are having classes and we are having objects, so how those classes and objects interact with each other is very crucial, and this is the fundamental functionality of a object-oriented programming. So that's where Java, being an object-oriented language, it provides mechanism to model this relationship through association, aggregation, and composition. So how do I relate these classes? So there is a way to do that one, which is called as association, composition, and aggregation, but which is needed for the classes to communicate with each other, to have associated with each other. So aggregation, association, and composition in Java describe how instances of class relate to each other. Yeah, as I mentioned to you, how they are connected with each other is all what we have in relationship between the different type of classes and how they are related with each other. So let's go and see what is association, composition, aggregation in detail. So one by one, we start with aggregation. So aggregation is a simple specific form of association. So the thing is important one is initially start is association, in which one class, the whole contains a collection of other classes. So you have one class which is having a lot of things inside a class. The parts here, however, the life cycle of the parts does not depend upon the whole. See, for example, a library and a books. So aggregation. So you know what is a library. So in a library, you are having a lot of books. Okay. So we are having a library and we call it as a lot of books are there. So if I am having a lot of books inside a library. So what do we have here? This is a library. So a library and book show aggregation. What does it shows? Is a specific form of association in which one class, the whole contains a collection of other classes. So if I make it a class as a library, so I am declaring a class as a library. Now in the class called as a library, and now we are having book. So this is one book, this is one book, this is one book, this is one book, and this is one. So what does they have in a library? You have books. So now that is where we call it as aggregation. For example, a library and book show aggregation, since books may exist somewhere apart from the library. So they can be in the library or it can be any other place that you can talk about, as maybe in a bookstore of that particular kind. Now, if you talk about the opposite of it is composition, is a stronger form of aggregation that means ownership and life cycle dependencies. If the whole gets destroyed, then the parts no longer exist. So composite, it consists of, it is form of, like for a composition, a good example would be a house and its different room. So for example, if you're talking about a house and if you are having different rooms, And a room cannot exist without a house. So you cannot talk about the rooms without a house. So it is composition. So you can say that a house is composed of rooms. So the other way, a room is a room. But if you are talking about many number of different rooms, then is composite of a house, as we call it as. So in more detail about this association, like aggregation, composition. It aggregation means, as I explained to you, composition means it is consisting of, and association, it is considered a generic term to indicate the relationship between the two classes. So now association, it is directly the general relationship. So association can be viewed as describing a use A relationship where an object uses or in any way interacts with other objects. So this is uses A. Now, if you can look at an example here, so we are having a class called as teacher and we have a class called as student. And then we have an association between the class and the teacher and the student. So we have association over here. Association may be either unidirection or bidirection. So as I told you, it can be in one direction or it can be in a two directions and may exist in several forms. The relationship may be one, one to many, or many to many, but it is need not indicate ownership. So say for example, what we are talking about here is we are talking, let me clear off this one. So erase. So I erase this. Now, say for example, this relationship is between the student and class. We call it as association. And from that association, there is one teacher and there is one student. Yes, it is possible. So this relation is called as one-to-one relationship. The other one, there in a class you have one teacher and you have many students. So this relationship you can put it down here one, and you can put it down here as many as a star. And then this one is one to many relationship. Or you can have many teachers, you put a star mark, and you are having many students. So many to many. So that's where the relationship can be. So it means that one class teacher and you are having one class student, so you can have inheritance with the many classes and many teachers connected, or one teacher is connected with one student. So both can exist independently. So it can be independent also. If you don't talk about any relationship, you can have a teacher class separately and you can have a student class separately. So no need of any relationship with them. So that's where we call it as both can exist independently as such, but it is a generic term which is used for relationship between the two independent classes. And remember, the relationship can be of different types. It can be one-to-one, many-to-one, and one-to-many, as we can see more. So here you can see, as I gave you example, in association, you have one student and you have one passport for that student. So every student has got, you can say 0 to 1. So maybe a student has a passport or not. So we just say it can be 0 or it can be 1 if I put it down like this. And here you are saying that one department can have one staff or it can have many of the staff. You can star mark. So the next is unidirection. Only from one direction it comes up to. So you can say that one department can have one staff or it can have many staff. So this is bidirection. So in both the cases, but here every department, one single department has got one to many staff. So the difference is the connection between these. And next you are having many to many bidirection. So you can have both the directions possible. You can have many students, around 1 to 50 students, and you can take one course to 6 courses a student can take. So this type of relationship, what is that is you can make it as a Java, you can make it as a class. You know that already you are having a class student, and here you can make the members, you can make the methods, and here you are having another class called as department, and then you are having a department class, and you are having this one. And now maybe, for example, you are having a passport. So class passport is there. So now you want to connect this program, this class with this one. So what is the connection between this? So there will be a connection between this class and this class. When you are creating, it will be one class is related with one student or one passport. So similarly, the classes relationship will be described in that way. So you just now saw the type of associations you are having: unidirectional and bidirectional. What are those? This association is the one in which one class is aware and associated with another class. That is, the reverse is not true. So this is only in one direction. For example, the student class can be associated with a library card. So a student will have a library card. The other way is not possible. A library card will not have a student. So for the association where a student has a library card. So similarly, a library card does not need to know about a student. So it is simply it exists, but it doesn't have any relationship. Bidirection, in both the directions it is needed. This type of association, the classes are aware of each other and interact with one another. So in this example, a teacher class and a classroom class. So they can be associated bidirectionally. There would be a teacher assigned to a class, and a classroom would known when it is teacher is assigned to that particular class. So there is a two-way direction which is possible for bidirectional activities. So I guess it is clear now that what is association. We are having different form of association: aggregation, composition, and association. So what is the difference between them, and what is association when talking about the two different classes, and what is the relationship between them, and how do you go for it unidirectional and bidirectional? Right. So for the association, let's look at an example in Java. So for example, we are declaring a class as a bank, and we are having a private string bank name, and here we are having a object here, class employee. So we will be using this as the employee, and then we are having the constructor for this public bank, and we are getting this, and then we are having the get method and the set method, the mutators and accessors, and also we are having here set methods for the employees, and we have get method for this is a set method, and this is a get method for the employees. Now we go to the class 2. We have a class employee. Now you can see that we are having an employee constructor. So we have two different classes. So when you are having two different classes, now the next is the main method. I want to add the things from here and also from here. So public static void main employee E1. So what is that employee class? So this is the employee class that we are using in this association example. EMP1 is equal to new of employee. So the employee is Riddhi. So now the name is string. Riddhi will be set over here. So similarly, we are having an employee E2, and the name of that employee is Vijay. So we are having this one. Now I am calling the set method as employees, and we make it as a hash set of values. So employees is equal to new of hash. Now whatever the employees that we have added, we want to add it to that employees that add one, employee one, employees that add employee two, and these are added to the employee list. So we are creating and adding those to the employee list. Now we are having a class called as bank. So you can see here that we had already created a class called a bank, and now I am using this class in the main program, and also I am using this class also in the main program. So both of them are associated in the main program. So you can have here employee as a class. You are using the employee class here, and also you are creating an instance of a bank class here. So bank and set method for these employees, and for the enhanced for loop, you get the employees and print it out here. Once you are done, so this employee belongs to which bank? So you are setting the bank here and the employees, and then it will print out that this client belongs to this. So you have bank and you are having employees. So this is one class, as you can see, bank, and you are having different instances of this employee, employee one, employee two as objects. And when you talk about the bank, you are creating a relationship between the different type of employees, and the association is shown in that particular order. The next type of uh, relationship we can say is aggregation. Now, what is aggregation? Aggregation is a type of association that represents a relationship. So now here we talk about the relationship where one class is a collection of or container of another class. So now has, from the name it is clear that it has. So the previous class has some members, or the new class is depending upon the previous class. So it depicts has a relationship where the container object can exist independently, so it can be on its own, or and the container object can exist independently of the container, so it can be independent of each other. So aggregation is a specific form of association in which one class, the whole container, contains a collection of other classes. The parts here, however, the life cycle of the part does not depend upon the whole. So that's what, it doesn't have to depend upon the whole. For example, we saw that a library and book shows aggregations, since the book may exist somewhere apart from the library. So a book and a library. So you in a library it is consist of books, but book can contain independently. So it doesn't have to be always belong to the library. So similarly here, so a department is there and a professor is there. So now we know that a department has professors. Okay, yes, a department has professor, or a professor can be independent. So he doesn't have to belong to any of those relationships. So objects can exist independently. So a department can exist separately and a professor can exist separately. So similarly here, a teacher as a class, he has to be as a one to college, and a student can be independent, or he has to be belong to the college itself. So a teacher belongs to the college independently, and a student belongs to the college independently. So it is an unidirectional association, that is one-way relationship. For example, a department can have students, but vice versa is not possible, and thus it is a unidirection in nature. So you can see that a department can have the students, but you cannot have other way around. Without the students is not going to be present. So in aggregation, both parties can survive independently or individually, which means ending one entity will not affect the other entity. So it doesn't have to affect the other entity in bidirectional, as in the case of aggregation. And the last thing here is about the composition. So now what is composition? Composition is a type of association. It's same like an association, meaning one class contains the another. So it is directly contained, composed of, made of. So this association can be said as a part of relationship, and would denote that contained object is strongly connected with the containing objects as a whole. The parts cannot be without the whole, so it has to be composed of. So see for here an example, you can see we have a class called as tire, we have class called as a vehicle, and we have class called as an engine. So a composition is a restricted form. There is restriction in which two entities are highly dependent upon each other. So it is composed, so they have to be dependent upon each other. It represents a part of relationship, all those relationships what we are looking for. In composition, both entities are dependent on each other. So like what we saw in the aggregation, they can be independent, so they can depend independently on each other. But whereas in composition, they have to depend upon each other. When there is a composition between two entities, the composed objects cannot exist without the other entity, so they have to be dependent upon each other. For example, a good example would be a house and its different rooms. So a room cannot exist without a house. So there should be a strong relationship with the composition. So that should have. So similarly here, if you are talking about a vehicle, now vehicle, what does it has? It has got tires. So when you have tire, it is a vehicle. And also, if you have just the tires, it is not enough. You should have engine also. So you have an engine, and then only we call it as a vehicle is a composition of two different classes with the tire and the engine. So overall, the representation that we are having here using the classes. So we have a class A, we declared it, and we are having a class B. Now, class B is depending upon class A. So we can declare in the class B. So in the class B, you see, we are having this class B here. In the class B, we are creating an object of a class A. So we are creating an object of a class A here. So that is a uses a relationship. So class B is using the class A. Now, similarly here, you are having class A and you have class B and class A. So they are also, you can say that it has a relationship. So it is uses, and as well it has a relationship between. So class B has a relationship because we are directly using it over here with an object is equal to new. So either you use it in a method or you use it is directly we have without the method here is has a relationship. Now, the other form of is a relationship. So when you talk about class B is extended from class A. So when we talk about polymorphic inheritances, we will discuss these things in more detail. But now class B is extended of the class version. So whatever the things that you are having here, those things will be extended and they can be used in the class B as such. So this is directly you are talking is a relationship. So those two classes are in relationship. And here the classes are objects are used here. And here you can say that there is a relationship between these. So these type of three relationships needed to be in the classes. So overall, this is the summary of the three different type of relationships that you can say. So when you talk about association, it is generally between the two classes, and dependencies. Classes are related but exist independently. So it is important that we know the life cycle. They are independent life cycle. They can run on their own. Though there is no ownership, the strength is very weak because it is only associated. You have many relationship here, one to one, one to one, one to many, many to one, many to many. Example that we can see here is a teacher and student, and you are using a direct reference for this one. So similarly, it has a relationship. So you are talking about has, and what is the different type of strength that you have. An example is about a library. Your library can, and the books, you can have the books to be there to have in a library. And composition, so it's a strong. So a car without engine is not a car. I mean, it's not a vehicle. So engine is engine, but without a car. So there is dependent life cycles. So they cannot exist without the container objects, and that's where we are having it as a part of relationship for these things. So the last thing, when you are representing these things in your UML diagrams, you can represent this with the association is generally represented with a solid line. So you will be having the relationship between the classes with each other as a solid line. Or aggregation will be having, if you talk about aggregation, it will be having an empty diamond. So like this one, you are having a diamond. And composition, it means that it is composed of. So you will see this one as a filled diamond. And when you talk about the inheritance, when you are having many different classes and you are having those classes to be connected, so how they are connected with each other, how the classes are connected, how the diagrams are with the hollow diagrams, or you can have sometimes which is a dashed arrow also. So some arrows will be shown as a dash. So we can talk about these inheritances and other form of relationship in the coming classes. But now you have to look into what is association, what is composition, and what is the need of it. So overall, you can have a look into it. So in today's class, we were discussing about the different type of modifier based on the static. So let me clear off the screen. Okay. And yeah. So what are static modifiers that we discussed about? What is the use of it? How you can get those static variable if you want to use it for all the instances, how you can do that, and how you can declare as a final variable when you want to make it as a static variable, and how you can define it and how they can be used without the static word and with the members with the object references, how the values can be used. So with that, we can see that we have completed our unit number 10. And in the next class, we can discuss about the other object-oriented thinking, how you have to think as an object-oriented programmer and designer. Okay, with that, thank you and see you around.